Weather in Malaysia is characterized by two monsoons, namely the southwest monsoon, which starts from the end of May to September, and northeast monsoon from November to March. The northeast monsoon brings heavy rainfall mainly to the state on the east coast of Peninsular Malaysia and West Sarawak, while the southwest monsoon shows relatively drier weather. During the heavy rainy season, people will face a problem where they need to manage their clothes that have been successfully washed, but unfortunately, the bad weather caused their clothes to be unsuccessfully dried. Through our reading, there are some long-term effects when drying clothes indoors. Among them, allergies and asthma. This happens because of the air from the damp clothes that are dried will be trapped in the drying room, causing the bacterial growth to occur. In addition, fabric softener contains high level of acetaldehyde, which is a major cause of the cancer.
The problem statement of our project is that society encounters some problems such as they cannot predict the rainy time or forget about their laundry hanging under the clear sky for the whole day. Other than that, the laundry cannot be saved during rainy day when there is nobody at home.
This is the initial sketch for our custom-made project design. The smart clothesline is built with a stainless steel cloth hanger to support hanging the clothes. The cloth hanger or drying rack is used for drying clothes after they have been washed. It is made up of aluminum material that is recognized for being lightweight and flexible. In addition, this rack is also good for rust-resistant purposes. It can support about 15 kg loading capacity for every single drying phase. The body of the clothesline will be covered with an aluminum composite panel. The SCP is a building material that is commonly used as the lining to the external walls. The thickness of this panel is about 5 mm, which will be used as protection for the inner frame. Having a highly resistant to heat properties, this SCP can support the clothesline that is mostly exposed to extremely hot weather. Initially, the rain sensor circuit, which is used to detect the rain, is embedded and put outside of the clothesline body. At first, the AC motor will be attached and combined with the rack and pinion to move in and out of the clothesline. Due to some factors, the motor is changed into a DC motor. Next, the solar panel will run the fan while providing the power to the solar fan. The solar fan, which uses solar power to spin, is one of the options to dry the clothes during rain outside. The monocrystalline material serves as the photovoltaic light-absorbing material, especially in the manufacture of solar panels cell. This helps to absorb the solar energy, which converts the sunlight into electricity.
The complex engineering design is that we build and attach the DC motor with the threaded steel and nuts. The use of this material provides you a cheaper option rather than the linear motor. This DC motor implementation uses the same concept as the linear motor. It will move vertically to move the clothesline in and out of the sheltered place, which is inside the body of the clothesline. When we consider the main power problem, there are the pros and cons that will be provided with the specific method that we will use. The use of the solar as the main power is very costly. The inverter and the accumulator car battery must be used to convert and provide the power to run the whole project. Other than that, the use of alternating current sources has limitation also. We aim to build a project with a portable ability. By using the AC power, it will develop the project within a very limited move and distance that hence does not reach our target. However, the AC power can provide a large voltage that made the project run smoothly. After discussing with all the team members, We have come up with a solid decision where we use the direct current to suit the portable purposes, although it will provide a limited voltage to the system. Smart Clothesline had a rain sensor that will detect the drop of the rainwater. Hence, it will automatically move the laundry under the sheltered cover by using the direct current DC motor. The solar fan will automatically switch on as the ultrasonic sensor detects the obstacle. The solar fan will keep the laundry dry. The clothesline will move out using IoT system. The solar fan will automatically switch off as the ultrasonic sensor do not detect any obstacle. This smart clothesline can be controlled by using IoT Blink. The first button will move out the clothesline. The second button will move in the clothesline.
First innovation is we combine solar fan with ultrasonic sensor. When the clothesline moves into the shelter cover, it will trigger the ultrasonic sensor as it is detecting the obstacle, then makes the fan spin. This uses the concept of detecting the obstacle of the clothesline itself with a specific distance that we have coded in the Arduino application. Second innovation is the DC motor can be controlled by using the IoT. The clothesline can move in and out by using a phone via Blink application. The Blink application is a platform that allows us to quickly build interface for controlling and monitoring our hardware project from the iOS and Android device known as our smartphones. The SDG involved in this project is SDG 11, Sustainable City and Communities. How can we relate this project to the SDG? Basically, this project helps the community, especially working wives, to deal with the daily work routine. This target really matters when mostly the wife will care for the laundry. Inadvertently, when they go to work at the same time, it started to rain. They will have almost no time to shelter to their house. With the IoT and automatic rain sensor implementation, they will worry no more. They can control the movement of the clothesline from far distance, which can save their time from going back home. Socially, this project gives big impact to the people surrounding to keep on growing and using the technologies because nowadays, the technology mostly eases our life. Other than that, the community, especially the household and working wife, really need to highlight and use the smart clothesline where it can save much time from dealing with the problems stated. The smart clothesline is one of the products that help them to deal with the difficulties of controlling the clothesline, especially when there is a sudden change of weather which is raining. Plus, this project can impact the environment also when it reduces the consumption of carbon monoxide released when they come back home to just move the clothesline to a covered place of the house.
This project has its own originality. The first system, which is the solar fan, uses the concept of determining the distance or obstacle to make the fan spin. The ultrasonic sensor will detect the obstacle that then will run the fan. This is used to dry the clothes on a rainy day. Next, the custom-made design that we have sketched is used to be the body of the clothesline as the real prototype. Lastly, the circuit for connecting the combination of a set of a rain sensor, DC motor, and the bin application is built according to our idea and some sources because there is no connection made for three components mentioned in One circuit found, based on our research,